Back. Okay, so here's the deal. Just like anything we graph, it's not like it's always in the form that we want it to be in. And we want our rational function to be in this form right here because it makes it super easy to graph. Okay, so how do we solve that problem? We use a little long division, all right? So we use a throwback from our polynomials unit. And then we are going to be able to rewrite this function in this transformational format. All right, so as a quick reminder, if we were given, so g of x right here is basically saying that we're taking 3x plus 5 and we are dividing it by x plus 1. So the long division setup for that would be the x plus 1 goes on the outside and the 3x plus 5 goes inside. So we would need 3 to multiply to x plus 1 to get us 3x plus 3. And then we would subtract, which means we subtract everything, and we would be left with a remainder of 2. Okay, so you might be wondering, what good is this? Okay, well, what we just discovered is that 3x plus 5 divided by x plus 1 is equal to 3 plus 2 over x plus 1, right? Because we got 3, and then this is our remainder. That is dangerously close to this format. It's actually just backwards. G of x is 2 over x plus 1 plus 3, because that's a positive 3 out front. And now we know where our asymptotes are located. We know we have a vertical asymptote at x equals negative 1. And we know we have a horizontal asymptote at y equals 3. 1, 2. All right, what we're not entirely sure about is where some other points would go. So I'm going to substitute in, I'm going to make a little table. Like I said, when in doubt, make a table. So I'm going to make a table over here. And I'm going to pick a point on either side of my asymptote, my vertical asymptote. So I'm going to pick 0 because 2 over 0 plus 1 is going to be 2 plus 3. That's going to be 5. Okay, that's nice. And then I'm going to pick negative 2. So that's going to give me 2 divided by negative 1. So, 2 divided by negative 1. So it's going to give me negative 2 plus 3. So that's going to be 1. All right, notice how those are equally spaced. They're actually 2 units away from your horizontal asymptote. That should make sense because essentially what we did was we just dilated the parent function by 2. Now, just to make sure everything's all, in the places that it should be, I'm going to pick a couple other points. I'm going to pick 1 because that's going to be 2 over 2, which is 1, plus 3. So that's going to be 4. So if I substitute in 1, I get 4. And then I'm going to go with negative 3 because that's going to give me 2 over negative 2. So that's going to give me negative 1 plus 3. So in many ways, these graphs are still sort of symmetric, right? But they're odd functions, right? They have odd symmetry. So I'm going to connect my branches. Ooh. You know what? Sometimes you can't get it all one shot. Sometimes you have to kind of come from the middle and then go along each asymptote separately. All right. And the main thing is you just want to go to that asymptote and run right along it. Okay, so there we go. So you may need, key thing, you may need to brush up on your long division in order to do some graphing. Speaking of, here are 2 more examples. I would recommend you try to rewrite in our transformational form before graphing. So how about you pause this? These problems are also in the student journal, at least we were working with at the time of this video being made, on page 199, in case you were really tired of not having some graph paper to draw these, okay? So pause for a moment, try these 2 problems out, and come back and see how you do. All right, welcome back. So in this first problem, I do want to point out that sometimes you could use synthetic division, but it actually looks so funky, it's not really worth it in my book. It's actually, I think, a little easier with long division because all you're asking yourself is, okay, I've got a 1, so I distribute that, so I get x minus 5, and then I subtract everything, which means this negative becomes positive. So I end up with 7. So what I have is 7 over x minus 5 plus 1. That's my new, that's the same function, just written in transformational form. So then it looks like I'm going to have to shift down a bunch. So I'm going to put this axis way up here. Oh, wait, I'm sorry. It looks like I'm going to have to shift left a bunch. So I'm going to do this. And then I'm going to be up one. So I'm going to go like here. All right, we'll see how that works. So I've got a vertical asymptote at 5. Oh gosh, guys. See, every now and then, even I can do it backwards. Okay, so hold on. I'm just going to... Ah, that's so silly. Oh my gosh. Guys, I'm trying to color coordinate. It's just not working out. Okay, we're going to be fine. Okay, so 1, 2, 3, 4, 5. Vertical asymptote at 5. Whew, that took me a minute. Sorry, folks. All right, horizontal asymptote at 1. All right, and then we've got this 7 to contend with. Okay, I'm going to substitute in -2. Because that's going to give me -7 in the denominator. So I'm going to get -1 plus 1. So I'm going to get 0. So -2 is at 0. Way out there. All right. I'm going to substitute in -4. Nope, +4. Because that's going to give me 7 over -5. That's going to give me, 7 over -1. So it's going to give me -7 plus 1. That's going to give me -6. So 4 is at 1, 2, 3. I'm going to go by 2s. 2, 4, 6. All negative. So we're going to be right there. Okay. Now I've got one branch over here. Let's substitute in 6. All right. That's going to be at 8. So oh, guys, now my asymptote's in the wrong spot because I went by 2s. Every now it happens. Hopefully, you're getting a vibe that, hey, we can just fix it. That's why we use pencil, right? 2, 4, 6, 8. All right, and then what else would be not too terrible? Oh, we need to go like way out there to like 12 or something like that. Yeah. 12 would be our next nicest point because 12 minus 5 is 7, so that'd be at 2. All right, so here's what I'm going to do. I'm going to draw this guy slowly making its way, but it's got to be above 2. And there we go. There's our graph. Yeah, it'd be nice if it went a little bit farther, but I don't want to run out of room. All right, so if you haven't tried number 6, please do so. I do want to point out that some other ways you could take a look at this. You could look at the fact this is 2 over x plus 4 over 3 over x minus 4. So that can help you figure out that, hey, you have a horizontal asymptote at x equals 4. And fun fact, the factor up here, that tells you where your 0 is located. Right? Look at this guy. X equals -2 is where our x-intercept was located. Isn't that neat? All right, so like I said, we need to do a little bit of division. 2x plus 8. All right, not ideal. We're going to have to multiply by 2/3 in order to turn 2 into 3. So we're going to get 2x and then -24 divided by 3, so that's -8. Which then means we're going to subtract everything. So it's going to switch. So we're going to get 16. So this is really g of x equals 16 over 3x minus 12 plus 2/3. Not the prettiest function to graph. So I will tell you that every now and then, transformational form isn't like your favorite. Okay? but it can be helpful. What it definitely confirms is that our horizontal asymptote is at 2/3. So it's not going to be at a whole value, all right? And that's okay. It happens. So we've got a horizontal asymptote. I'm going to put 2/3 roughly here. 4 is right there. And then I know I have a 0 at -4. So it's way out here. And then what happens if I put in actual 0? I'm basically going to get 8 over -12. So that's going to be -2/3. 8 divided by 4, -2. Yeah, -2/3. So right here. All right, so I'm starting to get that shape going this way. Let's see what else might be nice. Maybe 2, maybe 3. In this particular situation, I would definitely. Here are a couple other points just to get us going. 2 and -2. Like I said, 2 works out, not so bad. And then that's going to help us finish off this branch. And then 5 is going to get us 1, 2, 3, 4, 5, 6, right? 1, 2, 6. And 8's going to get us at 2. So that's going to get us our second branch. Ta-da! All right. So hopefully you're feeling pretty good about those graphs. And here's one more example for you that if you want to try it, go for it. And you can certainly check your answer with your graphing calculator to see if it matches. But last thing I want to do with you before we go. So you should be able to look at a graph and say, okay, I know I've got some a value, x minus, well, where's my asymptote? Okay, it's at 3, so x minus 3 plus my k value, so that's 5. And then you just want to ask yourself, does it look like we have any dilation going on? But if it's just over 1, up 1, that's our normal parent. And it looks like it is for this particular example. So that means we would have a 1. And you can always just check, like see if you're right. If you substitute in 2, do you get 4? Looks like we're going to get 4. So that works out. All right. One more. See how, by the way, like see how we're not here at this point? That lets me know, ooh, we got some fanciness going on here. All right, so we've got y equals, I'm going to leave a here for the time being, x plus 0, so just x, right? And then minus 4. Okay, we've got 2 things happening. One, we are not here and here anymore in our like upper right and lower left hand corner for our branches. They're kitty corner, but they're opposite. So we must have a negative a value. And if I look, 1, 2, 3, I'm going to bet that we have translated -3, right? Because we have stretched 3 units away from that horizontal axis. Okay, so let's test this out. I'm saying that I think that the equation is -3 over x minus 4. And let's see if we're right. I'm going to substitute in 1. So that'd be -3 over 1 minus 4. That should mean I get -7. And I've got writing all over here, but I'm pretty sure that that's true. Yep, this point right here is at -7. All right, so this must be my equation. Thank you guys for listening. Have a good one. We'll see you back here soon. Okay, bye.